So the transfer of heat in the atmosphere happens in a few different ways. So the first way is through radiation, and so solar radiation is how we are actually receiving all of our heat, and that's where it all starts. And then once that solar radiation comes through, we can gain heat through conduction, which is a direct. So, conduction with a D is a direct, with a D, transfer of heat through solid surfaces, like a pot on a stove, a direct heat. Whereas a convection is the primary way energy is transferred from the earth, and it's actually the movement of heat through air. So, like a convection oven, you have a heat coil and you have a fan that is moving the air in your oven. And so here you can see is a convection cell. So anything that is warm, so warm air, hot air will rise. And then this cool air that's has sank will move in to replace it. And that's the basis of convection, but it's very important. It's very important for the heating of the earth, as you will see. We're going to talk a lot about convection. And so, since we're talking about convection, we need to know a little bit about air. So, the less dense air will rise. So, usually warm air is less dense, and so warm air rises. So, anything that is less dense will rise, where anything that is more dense will sink. The water vapor capacity, so the amount of water air can actually hold, is very important. So warm air can hold more water than cold air. If you think about the humidity in the summer, right, there's a lot more moisture in the air. Pressure is also very important when we talk about air. So there's something called adiabatic cooling. So as air cools, it has less pressure and more volume. And with adiabatic heating, as air heats up, there's more pressure with less volume. So the amount of molecules is more dense. So that's important to remember. And then finally, condensation. Air becomes warmer with condensation and will end up rising. So as the water is condensing out, the air will rise. These are all important factors that add into convection, and so we will have or have already done a convection lab to hopefully clarify how convection works and what it looks like. But there are these convective cells around the globe, and we will go over this more in class for sure if we haven't already. But it is based on the same concept of this convection. So you're going to hear this convection over and over again. You have this hot air that rises. When it rises, the water condenses out, and ultimately we get precipitation. That air then cools down and sinks, and then ultimately that air will flow back in to replace the air that has arisen. And so you get this cell, this convection cell, so warm air rising, cold air sinking, moving in to replace what has risen before. And so if we start at the equator, that air gets very, very warm, as we've talked about before, and so that air will rise. And so if you start at the equator, you can see these convection cells. Warm air is rising, it's cooling off and sinking, moving in to replace that air. And that happens all around the globe. So on both sides of the equator, you have these cells. And these are called Hadley cells here, which we will, there you go, right? So here are the Hadley cells at between 0 and 30 degrees latitude. So you have this warm air rising, the air cools and clouds form, rain falls, and this is why we have a lot of tropical rainforests in in equatorial regions. That cool, dry air descends on either side here at the 30-degree mark, which is why we end up with a lot of desert at this area or at this latitude, at these latitudes. And then that air moves in to replace it. And so that is our Hadley cells from 0 to 30 degrees. The next one, and unfortunately my bar is, oh no, hold on, bear with me. I'm going to keep going. You guys don't mind, right? Okay. So you guys can see that here my warm air is rising at 60 degrees, and the same convection cell is happening. The drier air descends at 30 degrees. And so I have another bit of rainy climate here at 60 degrees. And these are called Ferrel cells. And above that, you have these polar cells where the dry air falls at 90 degrees or at the poles, and which is why the poles are deserts, because they don't have any precipitation. And so here we can see the combination of all 6 convective air currents. So, again, these warmer air masses are rising, cooling, and falling, and creating these convection cells around the Earth. The Coriolis effect has a massive effect on these, because the Coriolis effect is going to push these air cells either left or right, depending on what hemisphere it's in. And this is due to the rotation of the Earth. So the air will deflect to the right in the northern hemisphere and deflect towards the left in the southern hemisphere. And so this movement causes the prevailing winds. And so the prevailing winds are the northeast trade winds here in from 0 to 30, or in the southern hemisphere, the southeast trade winds. Then you also have the prevailing westerlies, which are at the 60-degree latitudes, between 30 and 60. And then from 60 to the poles, you have the polar easterlies. And so here they are again, another picture. We will go over this in class. And so these winds are named after where the wind is coming from. So you have these trade winds coming from the northeast. So these are the northeast trades, and these are the southeast trades. Here are my westerlies. They're coming in from the west, and my polar easterlies coming in from the east.